Now let's go for the next aspect of this practical organic chemistry, functional group detection. So there are 5 functional groups are given for this study. One is the hydroxy group. In these 2 varieties are there. ROH is called alcohol function, and an aromatic system like benzene with OH is called phenolic function. Phenol group and alcohol group. We have 2 carbonyl functions, specifically the RCHO function is called aldehyde function, and the CO, both the sides if R's are there, we have a ketone function. So alcohols, phenols, aldehydes, ketones, and then a carboxylic acid, RCOOH is called carboxylic acid. Then NH2, this is called amino function, amine function. Even for the NO2 is also there, that is called nitro. Specifically in the advanced examination we have nitro also, otherwise 4 are there in the main examination. Let us take first alcohols and identify. ROH function is specially known as alcoholic function. How do you detect the alcohols? One test is there for this alcohols, that is a ceric ammonium nitrate. Ceric ammonium nitrate. This reagent is very unique, and when alcohol is taken, added this ceric ammonium nitrate, this is +3. Okay. So you have ceric nitrate and ammonium nitrate. So ceric with 3, ammonium will be 1. So 4 nitrates will be there, isn't it? Ceric ammonium nitrate. This is double salt of the ammonium nitrate and ceric nitrate mixture. When you add this particular one, the solution become red color. Red solution is formed. This is because of the ceric ion makes a complexation with the 6 alcohols. Ce+3 which make a complex with the alcohol. The reaction is said to be a complexation reaction. This complex contains the red coloration. So this is the one test for the alcohols. The same test if you do for the phenols, it will become fail. In fact, phenols with ferric chloride, neutral ferric chloride, you will get a violet or some brilliant colors are formed. This is the unique test for the alcohols. But alcohols also react another common test. Alcohols react with the sodium metal. They react and forms the hydrogen gas is liberated, and the compound becomes into the sodium salt of the alcohol. So sodium alkoxides are formed. We cannot detect whether it is formed or not, this one, but the hydrogen gas coming, one can easily identify. Hydrogen gas will be coming out just like alcohol is heated and it looks like boiling. It reacts vigorously with the sodium and gives out hydrogen. You can also identify whether the hydrogen is liberated or not. You just check with a burning matchstick, it burns more. Carbon dioxide seizes the flame, but whereas hydrogen enhances the brightness of the flame. That confirms the liberation of the hydrogen. So the alcohols liberate hydrogen. Even phenols also liberate. This reaction is a common to the phenols also, liberating the hydrogen. But this particular 2 tests are reactions of the alcohols. The other solubility tests will not work here actually, but the ceric ammonium nitrate and the alcohol test confirms the alcohol reactions. Now, let us go for the phenols. Second one is phenols. Phenols are when OH is attached to either to the benzene or any aromatic system. If OH is directly attached, that is called phenol. If OH is attached to a saturated system like methyl, ethyl, propyl, any saturated system, they are called alcohols. So, this is the phenol. Phenols will have the number of the tests are there, color giving reactions. One such reaction is when phenol is treated with the ferric chloride solution, neutral ferric chloride solution. Ferric chloride will have a chocolate coloration, but when that is added, you will get a violet color solution is formed. Violet color solution is formed. Dark violet, it will be almost like a black. When you add some water, you can realize exactly it is a dark violet color. What happening in this reaction is with ferric ion plus 3 ion, 6 phenols get attached. Phenol molecules are attached to the iron. It is once again a complexation reaction. A plus 3 complex ion is formed, which is having a violet color. It is also studied, it is not that all the types of substituted phenols will not give violet. If a methyl group is there like at orthocresol it is called, a methyl group at meta, that gives some other color like green color. A methyl at para will give some other color other than green, you will get red color and so on. So, ordinary phenol gives the violet coloration, but substituted phenols, even naphthals will give some white color and so on. Sulfonated phenols will give some other color and so on. So, only ordinary phenol will give, but it in general except the alpha and beta naphthal, all the substituted phenols will give some brilliant coloration because of this complexation. The solution should be neutral. Ferric chloride freshly prepared will be acidic, add some ammonium hydroxide, get it precipitated and then add some fresh ferric chloride solution, you will get the just clear solution is called neutral solution, that you must add it. The other test like phenol bromination. Phenol, when you add bromine water, bromine is not totally soluble in water, partially soluble, 5 to 10%. It is soluble depending upon the temperature. You dissolve this small quantity of bromine in water, prepare bromine water, add it to the phenol at room temperature, no heating, just mix it, that is enough. You will get phenol brominated, tribromophenol is formed, 2,4,6-tribromophenol. This will have a white color precipitate in fact. After bromination, you add it to the excess of water, the tribromophenol get precipitated as a curdy precipitate, white color precipitate is formed. This is also a wonderful test. Phenol can be diazo coupling reaction. This is also a good test. Take the phenol, dissolve in sodium hydroxide, convert the phenol into the sodium salt. Sodium salt of the phenol is prepared first. Take phenol, dissolve in sodium hydroxide, you will get this salt. Then take aniline, add NaNO2HCl. So, this is prepared from the aniline. Take a amino benzene and diazotize it by adding NaNO2 and HCl in separate test tube and cool it to almost 0 degrees centigrade. Prepare diazonium chloride. Phenol is dissolved in sodium hydroxide, prepare this one, then add it both under cooling. The entire diazonium salt will couple with this phenol and you will get a phenol joint with this N double bond N with another benzene. Both the rings are now coupled and this reaction is called diazo coupling reaction. However, as long as basic medium you can write sodium salt. This is called a azo dye, dark red color will be there, red color azo dye is formed. Again here depending upon the substitutions in the phenol as well as in the aniline, the different other colored dyes can also be prepared, but ordinary phenol, ordinary aniline will give this red color, the azo dye, and this is also a wonderful test. Phenols also give two more tests, we will see that also. Continuation of the phenols test, phenolphthalein formation. Phenolphthalein formation. So, take the phenol, add a phthalic anhydride. Phthalic acid means benzene with COOH, COOH side by side. So, you take anhydride of the phthalic acid, this is called phthalic anhydride. In presence of concentrated sulfuric acid, heat it strongly. Then a few drops is enough, but you have to heat it strongly in presence of no water anhydrous condition. This phenol is coupled with this one, you will get this phenolphthalein formation, which will have a right now in the acidic medium no color. Phenolphthalein is formed. Phenolphthalein is formed, but no color will be there right now. Colorless will be there. But this one, when you add excess of sodium hydroxide, first the acid will be neutralized, then you add little more sodium hydroxide excess. In basic medium, you will get a dark pink color solution is formed. That is because of the phthalic anhydride, that is phenolphthalein formed in basic medium, it exists as an ion and then it shows this pink coloration. However, the structures writing is slightly bigger structures are there, but in pink color formation, the molecular form will be the no color in acidic medium, but in base you add excess pink coloration formation is another test. Similarly, you have a one more test called Lieberman nitroso test. All the 5 tests are excellent tests. Take phenol, add a small quantity of the sodium nitrite NaNO2 and a few drops of sulfuric acid concentrated and heat it. You will get it first the dark green substance is formed, which on adding the excess of water, if you add it becomes red color. Then you add the excess of base NaOH, again excess you have to add. When you add excess of base, because it is strong acidic medium, add water, it will become weak acidic medium, red color, almost neutral medium. When you base add in the basic medium, it becomes a blue coloration. Deep blue is formed. A dark green becomes into red and then deep blue. These 3 colorations because of a compound called indophenol is formed. But the indophenol in the form of sulfate, it shows green color. Indophenol, when it is diluted sulfate get rid of, you will get pure indophenol is red color, and that indophenol in sodium hydroxide excess sodium salt of the indophenoxide is formed, sodium salt, which is a blue color. This test is called Lieberman nitroso test, is also very simple test, but the colors are one after the one, 3 colors are formed, which is unique test for the phenol. So, all these 5 tests, that is phenol with neutral ferric chloride violet coloration, phenol with the diazo-coupling reaction, phenol with the bromination, phenol with the phthalic anhydride formation, Lieberman. Phenol has solubility also specifically. Phenol is soluble in the sodium hydroxide, but insoluble in the bicarbonate. This is the unique test for the solubility test, which you can also relay to some extent. In addition to this color test, phenol solubility is if you take as a next supporting test, phenol is soluble in the sodium hydroxide, but however insoluble in the sodium bicarbonate. Both are bases only, but strong base it is soluble, weak base it is insoluble. That clearly shows the phenol is acidic, but weak acid. So, weak acid category generally we have a phenol, therefore, you can expect this solubility and then go for the phenol expectation.